Howdy, and welcome to Broken Tool Garage. This week, I'm going to be going over this Slant 6 engine right here. I'm going to show how that I go about checking the deck height, that is where the piston is in relation to the deck on the block. This one, it sets a little low, right? I'm going to show that calculation, which is the final calculation I need to figure out what my compression ratio is on the engine and how much I want to take off the deck of the block and the deck of the head. After that, I'm going to get into the spreadsheet that I made that helps me calculate that and figure out how much I want to take off each side of that, right? So, let's get technical. Alright, so here's some of the stuff that I got in. I'm trying to get a few of these little double cut burrs right here. These are the shorter ones that'll fit in my rotary tool, the Craftsman one. I also got some 6-inch ones over here. One of the things I'm doing with that is I'm trying to figure out what shape that I like. Here's kind of a, I forgot what it called, spherical. I don't think that's a tree one. I don't know all the names of these things. What I normally use for doing heads is my double cut Cobra carbide in my drill right there. So that's what I normally use. And I do a pretty good job, but when I'm getting into the areas I want to work, I want to get more radius in there and be a little more detailed, and this tool won't quite get me the level of detail I want. It's great for removing lots of metal pretty quick with my drill, but once I get it into the rough shape I want, I can come through and refine it with these. So these actually reach in there pretty good. So that's what I'll be doing. So there's some things that I know how to do. It's called pocket porting is what I call it. I don't port heads, I do pocket port or a cleanup or a prep job. All those are the same words. It's not going in and doing deep porting, but I want to get there. I don't know how much I'm going to do on this head because I measured my compression. It's not good. I can't make it good as far as getting a 10-to-1 or anything. So I got to figure out how to get that cylinder to fill more efficiently, which is going to be cam, and it's going to be valve seats and the bowl area, valves. I'm going to play around with valves, make sure they're bat face good. I haven't really found any high performance valves of these sizes, and it's like a 1.62 intake. So I did find some, they're 8mm stem. So these are 3/8 stems. Now, I don't know how that's going to work. But anyways, I got this book right here to guide me, David Vizard. I've been going through this, so I'm going to review this in the bowl area, and this reinforces what I already know, which is the very entry level. But it also is going to help me go a little bit further in developing specific areas for flow, which is going to be that low lift flow as soon as that valve opens, so that cylinder fills as much as possible. Because I don't have the compression, I'm not going to be able to get the compression on this thing. So that's going to be the name of this game. Okay, I went back and redid my number on here, and I was fairly close, but I wanted to dial this in a little bit more on checking my deck clearance. So you see the piston is at top dead center, and there's a pretty good gap down in there. Right, so I went ahead and got the dial indicator out, made sure I was on top dead center, and then I come through and check my deck height. It's over there, it's zeroed out. So I took my square right here, make sure I'm on the block here and here, so there's a lot of good surface area, and I made sure to press it down real good whenever I come up, and I just lifted up, carefully lifted up my dial indicator and set it down there. And what that'll do, that'll allow me to get a reading on that that depth right there. So that, and I'll come down, okay, that sets a depth plus this, then I just use my caliper to measure the thickness of this ruler right here. I did it a couple times, played around with it, make sure I was getting good, accurate results, and I'm happy with that. So I'm going to hang my ruler up before I play with it some more or whatever. But that's what I did, and we're down in the hole about 190 thousandths. So that plus my brain fart, that plus my gasket thickness, which I have that here, which I know that this gasket right here has a 40 thousandths. I'll look up the part number somewhere on here. So that's just, there's not a whole lot of options for this engine. It's you kind of take what you can get. But I got the part number right in there. I can take that, and I think it's a 40, because that's what I keep finding is it's 40 thousandths crush thickness plus the cc of the cylinder head, and now I can calculate my compression ratio. So one of the things that I do want to note is you see this piston actually sits a little bit higher on this Slant 6. There's a couple versions of rod, I think it's rod lengths, which play with your piston pin height. So I think this one has a little bit longer rod length, so the piston sets up a little higher. So I'm looking a little better than some of the other Slant 6s out there, but it's not no 10 to 1. So let's just go ahead and look at the calculations. I'm going to go to the spreadsheet and show you kind of how my calculator works. Okay, here is the spreadsheet that I made using OpenOffice to do compression calculations. This one just happens to be for the Slant 6, and I've prettied it up a little bit since I'm actually showing this. So what we have is our inputs, like what we went over. We have the cylinder head CC, that's what I had to CC them. Now, I said 58, but I'm going to say that, hey, I could be plus or minus 2, so that's 60 to 56. I know my gasket compressed distance is 40 thousandths. My bore is 3.420 because it's bored 20 over. That's the stroke. That's our deck clearance. The piston. So what that's talking about is I don't have a dome and I don't have a dish. It's just a flat top piston. So there's nothing that goes into that. So from that, it calculates my cubic inches per cylinder. 6 cylinders, 227.4 cubic inches on the engine. All right, from just this information right here, you can calculate compression. And what I have down here is the maximum compression I could get, which would be using our minimum CC on the head. The minimum compression I would have, which would be the maximum, so that's kind of my range, and then a nominal or average is 7.7 compression ratio is what I have on this engine. That's a little bit better than the factory one, some of the factory ones, but it's going to vary by whatever this deck clearance is, and I think there's a little bit of different rod length and piston pin heights, which affects the deck clearance, and then where did the cylinder heads come in. The factory was very optimistic. They said it should have in stock form 8.4. The pistons that I have are actually they claim an 8.2, but that's not really realistic as what we can see. This is what we measured, and that's the best way to come about it is what do you really have with all your parts in there. You don't know where the factory set the deck, you don't know where the casting is, and so on and so on. All right, so what we really want to get to is, let me pause for a second and I'll show this. Camshafts. So if I come down here, this is the one that I'd like to use right here. We got our description in here. Stock engine was 7.1. Compression ratios are ideal. Up to 8.2 with cast iron heads are good. So I don't want to go over the 8.2 compression ratio on there. So that's what we're going to calculate. So okay, so we know what we got now. I know I'm going to take some off the block, which I don't want to take a whole lot off the block. We'll just say we do 2 passes. It's about 3 thousandths a pass, so 0.006. And you see we changed down here. If I took 6 thousandths off the block, We're a 7.8 nominal. Now, how much do I need to take off the head in order to hit, let's just say, a nominal of 8, you know? I could probably hit that 8.2 with no issues because I can do some tuning. I'm working on the inside of the chamber of the head and stuff like that. So I'm not afraid if I go a little over 8.2, but we're going to make it where our nominal right here is going to be at 8.2. So this is where you can go into your tools and hit goal seek. So yeah, I could go in there and punch in a number, punch in a number, punch in a number, and eventually get there. But that's what computers are for, right? They're really good at that. So I've got my formula cell. I already have it highlighted over here, the G19 cell, right? I want it to be 8.2. And I want to get there by varying my head deck right there. Now, it's probably going to want a number bigger than 0 to start out with. No, it figured it out. Sometimes you got to have a positive number in there or a negative number in there to kind of get it started, but it figured it out. So I need to take 38 thousandths off the head in order to have a average of 8.2. So that, like I said, depends on where everything falls. Now, once I get done working on the head, I'm going to be removing some material off the chamber with the valve deshrouding, smoothing things out, getting some of those sharp edges off of there. So that'll mean that I'll probably re-CC the head, but that'll give me more of the range I'm looking for right there is an 8 to 8.2, which, like what we saw on what they recommend for the camshaft, is 8.2 is kind of where they want you to be at a maximum for that. So that is how you can calculate your compression ratio, just a simple little program like this. And what all you're really doing is you have your head CC. What I like to do is go ahead and convert that to cubic inches. I have hidden cells over here that's doing that. I'm not showing all the math behind here. So, but anyways, you calculate your cylinder volume based on that when the piston's at the bottom dead center compared to what it is at the top dead center. That's all you're doing, taking those two measurements. So if you'd like to know a little more on how to do that or make this program, I could go into that on a separate video, but that's what we got right here. All right, there we are. That's what I'm going to do with the block side of that. I have the head actually at the machine shop now, checking out the guides, getting it cleaned up, getting all that carbon out of there so that whenever I go through and do my pocket port on there, I'm not just making all this dust and I can see what's going on, right? That'll answer what I'm going to do on the valve side of the head. And like I said, get it all cleaned up. Oh, those studs, the 2 studs I didn't get out, I'll let them have fun with that. All right, so that'll tidy this one up. Next week, we're going to be on gym. What am I doing? Well, door hinge pin. So, lots of fun with that. Come hang out with me and at least watch me suffer on that one, right? All right, appreciate you watching. I'll see you next time on Broken Tool Garage.